Okay, so chapter 2. Domain range. Okay, now this chapter is basically about pairing. It's about systems of pairings. Now that might sound really strange enough for me to you, but in fact you've been seeing systems of pairing numbers with numbers ever since you were in years 7 and 8. Can you think of any that do that? Graphs, yeah? Okay, so every time you put just a single point on a graph, you're doing a pairing. Because you can ask of that point, how high is it? That's the y coordinate. You can ask how far to the left or right is it? That's the x coordinate. And so basically you paired an x number with a y number. What other systems are like that in maths?
When they're like, you have to use a machine and you put
Yeah, but just in regular Year 8 language, what would that be? Just algebra rules, isn't it? So y equals 2x plus 1. You just put the number 1 in there, what gets spat out? Number 3, you put the number 2 in there, what gets spat out? The number 5. So that's the system of pairing. Okay, anything else? Just brackets and commas, isn't it? That's pairing. Okay. What's important about this pairing is that there's an order to it. There's something on the left, something on the right. So 1 becomes 3, 2 becomes 5. 1 before the comma goes to 3 after the comma. The number on the x-axis and then the number on the y-axis. Yeah? So the order matters. Okay? Now another system you've seen for pairing are these strange diagrams that you learnt in chapter 2. So here's one of them, these kind of egg things. Yeah? And so this is how we did it. Yeah? So the 1 is paired with the number 4, the number 2 is being paired with the number 5. And there's an order to it. There's a number before at the origin of the arrow, there's a number at the end of the arrow. So it's just yet another system. Okay? 1 gets paired with 4, 2 gets paired with 5. In my diagram here, 3 and 3 doesn't get paired with anything, 6 doesn't get paired with anything. Okay? Now there are actually 4 categories of this diagram. I'm going to draw them up. It's category 1, category 2, category 3. And category 4. Okay, now do you remember the names of those categories? Just have a look at how they're different.
Oh.
Yeah? What's the name for the first category?
1 to 1.
1 to 1. And this one?
1 many to 1.
Yeah? So 1 to 1 means you only ever have single, like you never have any instances of one thing either being at the end of 2 arrows or at the start of 2 arrows. So that's what 1 to 1 means. If you can find an instance where the same item, the same element is at the end of 2 arrows, we call that many to 1. Because there are many things, I mean 2 isn't really many, but it's kind of many. 2 things pointing to the same one thing there. So this one is called 1 to many. Now, have you heard of this category here? Doesn't sound like you've heard of it. What's that category? Any ideas? Okay. What does the diagram look like? Describe the diagram.
Basically, it looks like a mixture of the other.
Yeah, it's a mixture of the other three. Okay. Oh, but you can have 1-to-1 mixed in with any of the others without it changing the category. Okay. So many to one means there's at least one instance of two elements from this side being paired with the same element from this side. One to many means there's at least one instance of the same element from this side being paired with two elements from this side.
So the second one and third one could both be 1-to-1 as well.
Yes, and they wouldn't be called 1-to-1.
Yeah,
The moment there's one instance, it doesn't matter how many of these little single pairings there are, you still call it many to one. Which means the best name for this is many to one and one to many. Okay? Don't call it many to many. Okay? Just express the fact that it's got at least one instance of this forking and it's got at least one instance of that forking. Okay? You cool with that? How's everyone going? Does anyone want to ask me anything? We all good? Okay. Okay, now let's just do some analogies for these things. Just from the real world, what's a good analogy for that situation? From the real world, not maths. What in the world is like that? Where just one thing gets paired with one other thing.
What did you say the answer was to? Like marriage.
Yes. Okay. So we're going to call it Western Orthodox. Yeah, Western Orthodox marriage. Okay. The reason why I've said Western and Orthodox is because there are some cultures, both not in the West and within the West, where you can have the same person marrying two people. Okay. And the reason why this is a good analogy in the West and in the Orthodox way is because traditionally it's not the woman and the man who get married equally, it's the man who asks the woman to marry him. So that's why it makes sense that there's an arrow there. It's not just a completely equal thing. And you know, there's all these rules like how the woman's parents have to pay for the wedding, etc., right? So order totally matters in Western Orthodox marriage. Okay? Now, what's this? What's a good analogy for this one? Or what's a good analogy for this one? I can tell you about to say it. What is